Yes. Fine. This is J. Ramakrishna, Assistant Professor, CSE Department. And last section we discussed about the direct file organization, some topics, introduction topics, and some topics about hash function, how to use, and collision occurs. When after that, collision resolution introduction topic. So here, collision resolution with the links we are going to discuss in this section, that is about Coalesced hashing. So we'll see uh, in Coalesced hashing, that is nothing but let's see what will happen this year. So whenever collisions occurs, we are chaining. In that, we are getting Coalesced hashing occurs. How it is? Let's see this one. Here we can use this pointer to connect to the elements of synonym chains. Previous section discussed about so the synonym records are chained together. Okay, by in the Coalesced hashing. See what happened here on the retrieval of this. Elements of synonyms chain are searched until the desired record is located or until the null at the end, which is indicated by null. So here, coalescing get together, meaning that get together. So when it will happen means when we want to insert a record with a home address that is already occupied by other record from a chain with a different home address. If I want to insert one particular record, it having the home address, okay, that is different with the that is home address. Node, other record is occupied. That is chained. That is chained from the previous successor. Okay, successor maybe have the home address. That a home address only it points. No new record. If I want to insert that home this home address, both home addresses are different. So that is whenever the two chains are get together, there is nothing but coalesce or grow together. So coalesced hashing is also I can also refer as direct chaining. I can also say it as a direct chaining. Okay, the two chains with record having different home address, nothing but coalesced and grow together, and coalesced hashing is nothing but direct chaining. So this is when you are using linking. Okay, synonym records when you are linking for what? Collision resolution. I want to decrease the collisions. So in this case, this is happening, collapsing happening. Okay, let's see how it is. Let's see, this is sample one. Here, two chains are collapsed. Let's see, two chains are collapsed. Yes, two chains. Suppose one change, suppose whenever it happen like this. So if I want to insert a X record, okay, home address is yes, okay, whereas a B record already occupied, its home address is T. Okay, here its home address is T. So that's why what happened. So that's why what happened. So there are two chains. This here the coalescing occurs. Here one chaining is based on A, B, C, D also. D. Okay, one chaining. Other chaining is that X, Y, X, Y. Other chaining is about X and Y. Okay, so yeah, see, there are get together. These are both are get together. Both are get together. So this is one chain, another. This is another chain. They get together. So that's why it is like this. So keys with coalescing. If I am not using coalescing, so this is separately we can take it. Okay, where ABCD form one set of synonyms and XY will form another set. When coalesced together like this, it will happen. Okay, and the next C. Yes. So here is only discussing about from this figure about whenever X record is collide with B record, which is not a synonym. of X, since B has home address R, I told you that B has home address R. Oh, it is not T, it is R. Sorry, it is R. Whereas X has a home address, yes. Okay, fine. Both are different. This B is pointing to here home address, whereas X having home address starting only. Here only it is before P is want to insert at R, but A is occupied, so that's why it is placed here. So that's why its home address is R, whereas X home address is S. So both are different. So in this case, only whole collapsing occurs. He's telling that one only. Okay. This will result more probes, more searching probes, searching. Okay, to insert or to retrieve or whatever that. So then, so non-coalesced have changed. No, not that much number of probes is required. Okay. Yes. Let's see now. So yeah, here I'm telling you when X is inserted, it is at the end of the chain sometimes. Okay. Sometimes it is stored at the end of the chain. Now let's see. So let's see, in the above figure, he's telling about 19 probes are required when you are using this with the chaining, 19 probes. Without chaining, we require only Coalesced hashing happening. So that is 13 probes because both without coalescing only, both are chaining only, sorry. So with the chaining, this is first one coalesced. So it required 19. So with the chaining, both are not coalesced. So at the time only 13 props required. Okay. Here, let's see in the coalesced hashing. Whenever I want to insert a new record, so it is made at the bottommost empty location. So how it is? So in the bottommost, the pointer is pointed. So and decrease the pointer from bottom to top when you are going to insert the new record. Okay. So that is whenever the collision occurs at that time. So that is only is discussing that, no problem. Like we are going to discuss with the example. The algorithm, this is the algorithm not required. Let's see the topic. Suppose let's see this Coalesced hashing. Yes, let's see this example. Uh, yes, fine. Let's see. Suppose you know that by using division method. So this is the table. This hash table contains the size is 11. So yeah, that's why mod 11. Key mod 11. Suppose if I want to insert this is one example. Here we are using division method hashing. So coalesced hashing is any method if you apply. If coalesced occur or not. Let's see. Coalesced. Yes, let's see this. Suppose 25, 27, 27 mod 11. That is 5 will get remainder. So it's stored here. 18, 18 mod 11. That's 6 we 18 plus 18 mod 11 means 7 will get the remainder. So it is placed here. Next 29. See what happened. 29. That is 29 mod 11 will get 29 mod 11. Still will get 7. Address is 7. Key address is 7. So here. So here 18 is already occupied. So what I need to place 10. Why 10? Why it is 10? Let's see this. Before before collision occurs, R is pointing at the end. R is pointing at the end means at the null. So whenever collision occurs, suppose 29 is collided with 18. So I want to, at the time R is decremented. R is decremented. That means last position, 11th position to 10th position. There 29 I want to insert. There 29 is inserted. These are the links. First of all are null. Only 7 have the link with the 10th address. 10th address having 29 because 18 and 29 home address is 7. Okay, where 27 home address is 5. So that is so that is the only. See next records. Suppose next, let's see this one. Next, after the 28, 28 means the 28 mod 11. I want to insert the 28, 28 mod 11. So it will be 6. It directly inserted. Address is 6 directly inserted without there is no collision. After that, 39. 39 mod 11 means 6 again will get. 6 will get it. So it is already occupied by the 28 in the 6 address. So see, previously R is at the 10th position. If we again collision occurs, R should point to the decremented with one value. That means R point to the 9 address. So in that I can store 39, 39, whereas 28 link is 9. Ninth position 39 is because 28, 39 are both belong to home address 6. Okay, where 28 is in home address, whereas 39 is stored in the address 9. How it is based on the R pointer. Okay, suppose if any want to insert anything, any collision occurs, we need to store here. Here, let us see it after 13. 13 mod 11, it is there is no collision. 2, the remainder is 2, that is the second address, it is stored here 13, and the 16 will next one is 16. 16 mod 11, that is 5 mod 11, so 5 will get the address. So but it is 77 is already occupied, so I need to increment R value to the 8, decrement to the R value from 9 to 8. Here I need to store 16 here, so 16, and then link 8th position, 8th address, 8th address 16 is here. 16, 16 and 20, 16 and 27 are having home address 5 here. Okay, like this. If you want, if any collision occurs, so what need to do? R should be point to here because empty one we need to see. Let's see. So next records I want to insert is 242 after 1642 suppose. So what will happen? 42. So here it is chaining. Linking is nothing but chaining. 28 chain to 39. So whereas 18 is chained to 29. So like this. Here also 27 is chained to 16 like this. Now suppose if I want to insert 42 and 17 records. 42 mod 11. What the answer will get? 42 mod 11. So 9 will get. See 9. So 9, but 9 is already occupied 39. The value record already occupied by 39. But here, one thing I want to tell, 39, 26, and 17. So 17, not 17. First, sorry. Later we need to insert. Here it directly showing that 28 and 39 are having home address 6. That's why it is showing by 6 by 6. Whereas this is one chaining. Whereas I want to insert 42, but ninth address directly. For 42, the home address is 9. So what happened? I need to increment. R is pointing to decremented to fourth position. Fourth position. Now R is here. Fourth position. 42 I want instead. It's 42 home address is 9. Okay, 42 home address is 9. So that is here collision. Here coalescing occurs. This is one chain. See here. 39, 39, 42, one chaining, whereas 28, 39 is again one chaining. Here both are 39 having two chains. Okay, here is coalescing, grouped together. So coalescing occurs, and next one is 17 I want to insert. This is 17, 17 mod 11, that is 6 I got. 6 is already for 28. So I will see here 30 based on this address. 39 is occupied by in ninth position. So then what we'll do, R should be previously point to here and decremented. If a vacant space is there, then R is pointed to third. If it is no vacant space, again decrement. If no vacant space, again decrement. Like this. Until getting vacant space, R should be decremented repeatedly. In third position, vacant space is there. Here I want to store 17. Okay, 17, yes. 17, 28, 39. One chain. This is one chain. And in the same way, yes, this is a forms a one chain. Yes. No, yes, fine. Whereas, yeah, this is about. Okay, fine. So this is easy. Another. This is one chain. This is one chain. This is another chain, and this. Suppose see here. This is one chain with home address 6. This is another chain with home address 9. So both are. See here, 2039 having two chains. This is a coalescing address. That is he's telling. This is the coalesced hashing. This is coalesced hashing. So here one method of coalescing is there. Whenever coalescing is there, more number of probes required. Then it will take more time to retrieve a record. So there are different methods are there to reduce the coalescing. So one is let's see this one is so that is about coalescing and then one is how to do one of the method to decrease that is based on packing factor or load factor. So whenever it is lower, there is the packing factor. Load factor is whenever it is lower, there is a less chance there will be a collision. A less chance there will be a collision from one chain with another chain. Okay, so but it is not. We also have other variants of coalesced hashing to reduce coalescing. Coalescing. So we'll discuss what are that. Yeah. Suppose it takes more time. If a particular record is not found, it will take more time. Ah, yes. Next. Next. Uh, here, yeah. Coalescing discussion that is about whenever coalesced hashing, we can also go to place records early in the instruction. Before only we need to insert. That is only discussing. Let's see the deletion. How what happened in deletion. After discussing this deletion operation, we'll see other variants to reduce the coalescing, deletion. So more complex schemes to reposition the records in coalesced chains. Let's see how it is deleting. So that meaning that if I so current record is want to remove it in a synonym of chains. I want to remove that is linked to the pre successor. Yeah, successor. Okay. If you remove that, so successor record should place in that current record position. Okay, this is applying recursively, so you will understand with the example. Let's see this. So here, to delete the record 39, I want to delete the record which are inserted previous example. 39 I want to delete. 39 I want to request that here both coalescing occurs. Here the coalescing occurs. I can't delete directly. So I want to delete. I can't delete it directly. Let's see this. That is only discussing. Suppose what I will do. Yes. Suppose say I want to delete 39. Suppose yeah, here the address is 9. I'm taking one chain, this chain. If I'm deleting this 39, the successor is 42. In the chain, that successor is 42. So 42 should be placed here, and it is may leave it as a vacant space. So leave it as a vacant space. Uh, Vacant space. Whenever vacant space, before vacant space, I can place R as fifth position. Okay, if it is happen vacant, R as a sixth position. Suppose this 42 is a link chain to 42 is chain to suppose one position something value is there. Okay, if I want to delete 39 means I should place 42 here, whereas this one position value should be placed here, and R is point to the one position. So I told you that recursively we can apply. That means the current record if I deleted, the successor record in chaining, next link, that record should be placed here. Whereas that record is also pointing to another record means chaining means that record is placed to that this position. So like this, this one position value should be placed 42 position, 42 should be placed in the 39 position. So this is the way of deleting whenever Coalesced hashing occurs. Yeah, that is only discussing that what happened after deleting, what happened, 42 come here. R is pointing to here. Here is a vacant space is there. Suppose one position value is there. If it is space means R should be second position. R should be for second position. There are now we'll discuss. To decrease one thing, I told you that by using the load factor or packing factor, but another variants are there to reduce the coalescing. That is, one is a table organization, another is matter of linking a colliding item into chain, and the matter of choosing unoccupied, not unoccupied locations. And now let's see this. Let's see. Yeah, discussion is over. And after deletion variants, first variant table organization. Table organization is divided as address factor, primary area by total area size. Here, this is the formula. So this is the primary. Whenever the flow occurs, I can place the records here. Okay. Here the address factor, whenever the address factor increases, uh, whenever the address factor decreases, cellular size increases. Okay, this size increases, but it reduces the size. It reduces the coalescing. Whenever this increases, it is decrease. Whenever the address factor decreases means that overflow. This part will be incremented. In this way, we can reduce the coalescing. But whenever decreasing this primary area part, if you after increasing this, collision occurs. That is the problem. So it is not a practical solution. Okay. So address factor should be the optimal value 0.86. If it is decreases means collision occurs. That is the problem. Even reducing the coalescing, collision occurs. If the coalescing is there, more number of probes is required, more number of times to place. Whereas a collision means, yes, both are problem. Now let's see the other variant. Yeah, previously we discussed about whatever that algorithm 3.1 means. Previously that algorithm, Coalescing hashing algorithm, that I can also say it as another name, L LISSCH, that is a late insertion standard Coalesced hashing, whatever we discussed. Because from the end only, new records are inserted at the end of the chain every time. From end, our point is first time it is to the last position, the pointed. So when I want to insert a new record after collision occurs, I decrement the R value from last, and then I can point the R value to the newly inserted record. So this is a LISSCH. Another variant is cellular. Variant is LICH, late insertion Coalesced hashing. This is the late insertion Coalesced hashing, that is by using this primary and overflow. See here, what happened? So 27 is placed sixth position, no problem. 18 is placed here. 29, whenever 29 occurs. 29, what is the 29? See here, one thing, how I am placing. So I divided the parts. Here, this primary part, I will take the size as 7. This part I will take as the size of 4. Let's see what will happen. 4 11, I think 11, sorry, 11. Let's see first of all. First we'll see. Yes. Let's see this one. 7. Okay, we'll see. Yes. Suppose if I'm taking 7 mod size, 27 by 7, 7 4 is 20, 7 3 is 21, 6 position, yes, 27. 7, if I'm taking mod size 7, and 18. 7 2s are 14. 18 minus 14. 4 I will get it. So it is 18. I can place the fourth. And 29. 7 3 is 7 4 28. 1 position. No collision occurs. And 39. 7 some 5s are 35. But 4 position 18 is there. So what I will do, first R is incremented from decremented to 10. 39 I place here. After that 13 will come. 13 7 more 13 7 1 is 7. Sixth position 27 is there already. So R position is decremented to 9th, and I can insert 13 here, 13 here. So here link is 9. For 18 also 10 is link 39. 16 it is next. 7 2 so 14 2 2 there is no collision. 16 will place here. 42 next will come. 7 6 42. 7 6 42, but 0 will get remainder. So 28 already occupied. So what I can place this. So eighth position. That means R is decremented to 8, and here I insert 42, and next 17, 7 to 14, 3. Third position is not occupied. This is the late insertion. Late, what is that? Late insertion coalesced hashing. Coalesced hashing. So that is this is the first technique to reduce the collision, and second variant is second one. No, second variant. Table organization, that is the first one. Second one is the manner of linking a colliding item into a chain to reduce the Coalesced hashing. So we know that a variant called here I can use the hashing is nothing but yearly instruction standard Coalesced hashing. So here what I will do, new record can be inserted into a position on the chain immediately after the record stored at its home address. So how it is happening, what will happen, let's see this with example. Clearly we'll see with the example. Well, with example. Oh, yes. Yes, yes. Here the chain is greater than 12. And, yeah. So we know this actually up to this point we stored here. Yes. So when I want to insert 17, suppose this is up to know both previously LI, SCH, same. Okay. Same results. Until the chain is greater than 2 elements. So LISH, ASH is 2 elements linking chain. So both are same, but whenever I insert in the chain third element, what will happen for the third element? Suppose if I want to insert 17 in when we insert 17, 17 mod level, 11 mod 6 position, actually 28 is there. 28 is there. And let's see the ninth position, 39 is there. And 17. R is pointed here previously. Now it is decremented 3. 17 I place. Okay, 17 I placed. Yes. That is 17 I place. From link, yeah, when I want to insert 17, yes, 17, that is 6 mod 6. 11 ones are 11, 6 will come. Here it is occupied. So what previously 28 is pointing to ninth location. So how it is changed, let's see. We'll see. So 17. So after linking, 39 is already occupied. So whenever R is decremented from 4 to 3, I can place 17 here. Whereas 17 is linked from 9, whereas 28 chain, this is home address 6, this record linking to directly the last element in the chain, last element, that is 17. What is the chain we have? 28, 39, 17. So previously 28 having 9. Now it is pointing to the, in the chaining it is pointing to the last one. This is the address 3. Address 3. 28, 39, 17. So in that previously 28 having linking to ninth position, but but okay, only whenever two elements are there. And when a third element is there in that chaining 17, so here see here first node link, first address, this home address link is given to last in the chain last node address, that is 3. So that is okay. Now next one is 42, 11 mod 42, ninth position, it is 4. No, it is 29, 39, 4 is 42 is placed here. It's fine. Yes, this is when I'm inserting 17. This is the difference between ESCH and LICSCH. Okay, third variant is there. Third variant just to describe randomly. Yes, yeah, randomly we can place the collided items records randomly. That is REISH. It's somewhat 1% improvement than the EISCH. Okay, so unoccupied position randomly I can place. In an unoccupied position randomly I can place the records. So maybe random here or here. Uniformly I can distribute the whenever collision occurs without following chaining. So that is one. This is enough. Another one also is the bidirectional LICSH. No, this is enough. EISCH. This is third variant. First variant we discussed. First variant is LICH. Discuss. Second variant we are using EISCH. Third variant using REISCH. Okay. So this is about hashing, Coalesced hashing. So this is about Coalesced hashing. Next section in the direct file organization only. Direct file up to no direct file organization. We discuss up to Coalesced hashing. So next section we'll discuss progressive overflow. What is the use of buckets, linear quotient? What is this? These topics we'll discuss next section. Okay. So today's topic we covered Coalesced hashing. What is the Coalesced hashing? Yes, Coalesced hashing. So number of loops increasing in Coalesced hashing to reduce that. This is Coalesced hashing algorithm. So how the coalescing hashing occurs. So this is we discussed. So whenever the same node having to change at the time coalesce, the chains are coalesced to get together. So at the time number of loops are required to insert a new records. So this is about deletion. How we can delete in the Coalesced hashing. Whatever the successor record can be placed in the current record. Recursively, this is applicable until the no record is found in that chain. Okay, this is the deletion. And to reduce the Coalesced hashing, there are 3 methods. These are the 3 methods by using. One is by using LICH, late insertion Coalesced hashing. Normally, previously we discussed this previous one. We discussed LICH. It is, and second method, that is I by using the EI yearly. Yes, EISCH. What is that? What is it? EISCH? Yearly insertion standard Coalesced hashing. And third one is that REISCH. Randomly, in an unoccupied position, we can store the records without following these rules. So that is the thing. And next section we'll discuss about progressive flow, linear quotient buckets. What is this? We'll discuss next section. Okay. So this is about the today's topic.